Okay, so the class is now recorded, so I will share my screen. Okay, so can you see my PowerPoint slides, students? Can you give some response if they are visible to you? Thank you. Okay, thank you, Yashvin, for your response. Okay, students, so yesterday we've started with 6.1, refraction of light. And for today, we will continue with 6.2, total internal reflection. So I hope you are there with your module. So without further ado, let us begin with our lesson today. All right. Okay, 6.2, total internal reflection. Actually, this is another phenomenon involving light other than refraction of a light we learned yesterday. So in this content standard, there are 4 learning standard we should need to know very well. Okay, so first let us take a look at this daily occurrences. Diamond. Who don't know diamond? The most precious gems on earth, the most expensive stone on earth. All right. So if you look at this GIF, you can see the diamond is shining here and there it's sparkle. So any idea what causes the diamond to sparkle, students? Can you think some idea what causes the diamond to sparkle? How it able to sparkle that way? Is it due to the shape or due to the composition inside or due to any physics phenomenon? Anyone? We have Chiayi there. We have Jia Zheng, Wen Han, Kai Wan, Wang Jiala. So far we have 49. So the reflection of light. Okay, Yasmin say reflection of light. Okay, thank you for your uh, idea. Okay, what about the rest? What do you say? Any other opinion? Or any other idea what causes the diamond to sparkle. So this will be closely related to our topics today, total internal reflection. Okay. Okay, students. So the first learning standard, 6.2.1, we are going to describe what is critical angle. Second, what is total internal reflection. Okay, so actually the phenomenon that causes the diamond to sparkle just now is total internal reflection. Okay, so students, in this activity, you can find in your textbook, this is to observe phenomenon involving total internal reflection and to determine the critical angle of glass. So here we are using semicircular glass block as you see in this diagram. So all the apparatus and materials needed are as listed. All right. So this is the procedure. So the arrangement of apparatus, as you can see, we directed a ray box at a certain angle to the semicircular block at the side, and you will see initially refraction will occur. And then later, when we increases the angle of incidence, you will find the angle of refraction is becomes greater and greater, and finally refraction stop occur and replaced by total internal reflection. Okay, so the instruction or procedure, I think you can read from number 1, started from drawing a straight line AB until number 8, where we place the glass block back to the original position. So our observation will be on the angle of incidence and angle of refraction. All right. So this is one example of demonstration how is this experiment conducted. Sorry. Okay, so this is the related video so you can see. So this is our arrangement of apparatus. The ray box is there. So this is the drawing we drew earlier and we place a semicircular glass box at that position. And then we incident our ray diagram, our sources of light at a certain angle. We begin with I of 10 degree. Okay, so when I is 10, we determine angle of refraction is 13. Okay, then when we increase to 20 degree angle of incidence here, angle of refraction will be there 33 degree. Okay, and then when increase to 30 degree angle of incidence, as you can see, okay, there is 30 degree, so angle of refraction there is 47 degree. Okay, then we increase again to 40 degree. Okay, okay, now this is 40 degree. So you will find the angle of refraction is 74. Alright. And then when we increase to the next angle, okay, so now you will see that at this angle, okay, before that, okay, here at angle of 41 degrees Celsius, 41 degree, you will see that the angle of refraction will be exactly at the border, where angle of refraction is 90 degree. Okay, and then when we increase some more to 42, okay, so you will see all the light will be reflected back to the semicircular glass block. So here, total internal reflection occur and refraction has stopped. Okay, no more refraction, but what happened, the light is reflected internally, mean reflected back to the glass block. So we call it as total internal reflection. Okay. And here now the angle of incidence 50 will be equal to the angle of reflection. So now we call it as angle of reflection, which is also 60 degree. Okay. Same do with 50. All right. Okay. So what do we observe from this study? If you look at the angle of incidence, as angle of incidence increases from 10 to 42, you can see that angle of refraction also increases from 13 to 90. So then 90 degree is the maximum angle for refraction to occur. Okay, I repeat, 90 degree is the maximum angle for refraction to occur. So after that, so after 42, what happened? 43 and above, when the angle of incidence 43 and above, no more refraction, but it is replaced with total internal reflection. All right. Okay, so this is the first activity. So from here, we can find, we can determine or define the first term, which is critical angle. So what is critical angle, students? So you may write this. Okay, critical angle is defined as the angle of incidence in the medium of high optical density. For example, here we have glass and air. So glass is a medium of higher optical density. Air is a medium with lower optical density. So when the light travels from glass into air, so angle of incidence here, so what happened? Refraction occur. Okay, so this is the angle of refraction in air. So what happened when I increases, R also increases until it reach one point where R will be exactly at the boundary between glass and air. So when that happens, so we call the angle of incidence in this glass as critical angle. So I repeat, what is critical angle? It is defined as angle of incidence in the medium of high optical density when the angle of refraction in the medium of lower optical density is 90 degree. Right? So I hope you are clear with the first definition for critical angle. Okay. Okay, any questions so far? Anything you would like to ask? So I hope you're clear with critical angle. Okay, now we go to the next slide. Okay, so the next slide is to write the critical angle of the glass. So what is the critical angle of glass according to this experiment, students? So the critical angle of the glass is 42 degree. Actually, this one I screenshot a bit later. Actually, I should screenshot more to the back, so you will see the light refracted exactly at the border. Okay, so here the critical angle is 42 degree, where angle of refraction is 90 degree. Okay, so 42 degree is the critical angle of the glass using in this experiment. Alright, okay then. Okay, we look at this GIF. I can see another example. Okay, how when I increases, R also increases until maximum of 90 degree. Okay, so if you look at the GIF, when R is 90 degree, I is also called as C. I equal to C. C is critical angle. And here, students, you will see when the angle of incidence now greater than the critical angle, so total internal reflection occur. Okay, where the light ray will be reflected back into the glass medium. Okay, so this is to answer question 3. What happened to the light ray traveling through the glass block when the angle of incidence smaller than the critical angle? So when I smaller than C, what happened? Refraction occur and the light will be refracted away from normal. Why away? Because travel from higher optical density to lower optical density medium, from glass to air. Okay, and then in the second question, what happened when the angle of incidence is larger, greater than critical angle? So I now greater than C, you can see, so what happened? The light ray will now experience total internal reflection. So in short, total internal reflection begin with refraction when light travel from denser to a less dense optical medium. Right? Okay. Okay, next students. Okay, this is the definition for total internal reflection. Okay, so what is total internal reflection, student? It is a phenomenon. Okay, you may write this. The phenomenon occurs when light travel from a medium of high optical density, in this case glass, okay, to a medium of low optical density, which is air, with the angle of incidence greater than the critical angle, I greater than C. So there are two keywords here. The yellow wording is the keyword first. The light must be traveled from medium of high optical density to a medium of low optical density. Second, angle of incidence must be greater than critical angle. I must be greater than Z. So that is the two conditions for total internal reflection to occur. Right? So are you clear with that? So first, we look at the definition for critical angle. Second, we look at the definition for total internal reflection. Right? So next slide. So this is the conclusion we can make from activity 1. First, what happened when I less than C? When I less than the critical angle, so the light ray will be refracted away from normal, as you can see from this diagram and also the GIF here. Okay, and then next, what happened when I equal to C? When I equal to C, what happened? The light ray will be refracted along the glass A boundary, where the angle of refraction is 90 degree. Okay, here as shown in B. Alright, okay, then next, what happened if I greater than C? As shown here, I greater than C, where C is the critical angle. So no more refraction, but total internal reflection will take place. Right? No more reflection when I greater than C, where total internal reflection occur. Okay. So can you see the sequence started from refraction, I increases, R increases until R reach maximum angle of 90 degree, and then we keep increasing the I greater than C, so total internal reflection occur. Alright, okay, next. Okay, this is what I mentioned just now. The two conditions it must obey for total internal reflection to occur. Number one, the light ray must travel from medium of high optical density to medium of low optical density. For example, from glass to air, from water to air. Okay, second, I must be greater than C. Angle of incidence must be greater than total internal reflection. So it must fulfill these two conditions, then only total internal reflection occur. Alright? Okay. Next, let us try this. Okay, question number 1 for this module. Okay, we have diagram 11 shows a fish with its image in an aquarium. So you can see the image is at the surface of the water, the fish is below. So this situation explain which phenomenon? Is it total internal reflection, refraction, diffraction, or interference of light? Okay, so which one? If according to our topic, it should be on total internal reflection. Okay, the light is travel from the fish. The fish is the object. So light travel from water into air. And somehow I is greater than C. So the fish will observe its image on the surface of the water. Right? Okay, what about second question? Which of the following diagram shows total internal reflection? Is it A? Is it B? Is it C? Or is it D? Okay, which one for question 2? Okay, share your answer in the in-call messages. So number 1 answer is A. What about number 2? A, B, C, or D, students? Okay, let's see. Chi Hang say B. Okay, now respond for question 2. Which diagram shows total internal reflection? Okay, remember the two conditions. Light must travel from denser to a less dense optical medium. And then second, I greater than C. Okay, Chi Hang say B, Ru Yang say A. What about you? What do you say? Students. So Yong, what do you say? Jiale, Chia Yi. Who else we have here? Johan, what do you say for question 2? Wai Chin, Kai Lun, Pion, Jacqueline, Kai Wen. We have Yi Wei, Yu En there, Charmaine, Son Yin, Oi En, Kiat Min, William, Jia Hao, Jun Bin, Ui Hen. Wan Xin, what do you say? Question 2. Is it A, is it B, is it C, or is it D? A, this is plane mirror. The light travel from A to the mirror when made. So A is a reflection. For A, the phenomenon is reflection. Okay. For B, the phenomenon is refraction. Okay, refraction from glass block and then refract to the A. Okay, refraction. So what about C? This is glass prism. The light travel from air entering the prism and then from prism here to the A, but it doesn't refract out. It reflected back internally. So C is total internal reflection. D, what about D? D is refraction. Okay, so answer for second question is C. Okay, total internal reflection. So here you can see I equal to R. A reflection only, B and D refraction. So C is total internal reflection. Okay, are you clear with that for question 2? Okay, so you can make correction if you choose the wrong answer for number 2. Okay, next. Okay, what about question 3? Okay, now this diagram shows light ray P. So this is P. okay, below, incident to the glass block. Okay, given that the critical angle of the glass is 42 degree. So here, 42 degree. Okay, so the question is, in which direction will the light ray emerge from point Q? Okay, students. So, in which direction will the light ray emerge from point Q? Okay, so it enter here from down here and then it reach the border. So, this is the normal. Okay, the normal. So, what is the angle of incidence here? Angle of incidence is 42, equal to the critical angle. So, now I equal to C. So what happened to the angle of refraction? Will it go to A, go to B, go to C, or go to D? Okay, question number 3. What do you say? The clue is I now 42 equal to C, 42 degree. So what happened when I equal to C, students? So Jiaren says C, Chi Hang says C. So what happened? The angle of refraction will be maximum. Okay, when I equal to C, angle of refraction will be maximum at 90 degree. So it will refracted exactly at the boundary between the glass block and the air. Okay, so answer is C. Okay, let's say we put angle here. If the angle here 41 degree, if the angle of incident 41 degree, so where will the light ray go? So it will go to B, refracted away from the normal. But if here 40 degree, okay, now if angle of incident here 40 degree greater than the critical angle, so what happened? Total internal reflection will occur, so it will travel through D. Okay, so that is the difference. When I less than C, it is refracted away from normal to B. When I equal to C, angle of refraction will be maximum at 90 degree. And when I greater than C, total internal refraction occur, so it will travel through D. Alright? Okay. Then number 4. Okay, now we are having this situation. Given the critical angle of a colored liquid, so color liquid is here. Okay, for A, the color liquid is here. Here also color liquid down. For C, the color liquid is also here. Ini pun di bawah the color liquid. Which of the diagram shows total internal reflection? So our medium is air and colored liquid. Given the critical angle for the color liquid is 48 degree. Right, so which one for number 4? Which one is the correct diagram shows total internal reflection? So you have to obey the two conditions. Number 1, the light must travel from denser to a less dense optical medium. Okay, so let us see some response. What are your friends saying for question number 4? Okay, no response yet. No try yet. Okay, so we look at A first. Okay, here A, the light is travel from air into color liquid. So you can reject A. Okay, why reject? Because now the light travel from less dense to a denser medium. Air is less dense compared to any liquid. Okay, what about B? B also rejected because the light travel from air to color liquid. So we only have C and D left. Okay, C and D left. So the first condition obey, travel from liquid to air. This one also travel from liquid to air. Now we have to look at the second condition. I must be greater than C, which means I must be greater than 48 degree. So here I 46 degree. Here I 50 degree. So the answer is now obviously should be D. Okay, it obey both conditions. First, light travel from high optical density to less optical density medium. Second, angle of incidence greater than critical angle of 48. Okay, so answer is donkey. Right? Okay, so that is the first learning standard to understand and to define critical angle and total internal reflection. Right? Okay, now the second learning standard, how to relate critical angle with refractive index. Remember yesterday we learned refractive index with this formula. Okay, now this is the fourth formula, okay, involving n and critical angle. Remember we learned three formula involving refractive index. If you remember, if you forgot, never mind, I'll remind you. The first, n equal to c over v. C is speed of light in air or vacuum, v is speed of light in medium, okay. And then second, n equal to sine I divide sine R, where I must be the angle in a less dense medium and R must be in a high dense medium. Okay. And then third, n equal to real depth divide apparent depth. So this is the fourth formula involving refractive index, and somehow it is related to the critical angle C, where n equal to 1 over sine C, or we say n equal to reciprocal of sine C, right? Okay. So this is the second activity to understand n equal to 1 over sine C. Okay. Remember Snell's law we learned yesterday? Okay, as I mentioned just now, n equal to sine I divide sine R. So we started with the second formula for Snell's law, where I always in a low optical density medium. R must be always in high optical density medium. Okay. So here what happened, if you look at this diagram, the light is, we apply laser pointer here at this angle. So the light travel from glass into air. And now here I is equal to C. That's why R is 90 degrees. So this is the incident ray. This is the refracted ray. Okay, and N1 is the refractive index for glass, N2 is the refractive index for A, as shown in this diagram. Okay, so what happened? So I here 90 degree. So we reverse, student. Okay, we use the principle of reversibility of light. So we reverse the arrow. Okay, when we reverse the arrow, so now 90 degree, this is become I. Okay, I 90 degree. Sine 90 degree equal to 1 if you press your calculator. Okay, so now this one, C, become our angle of refraction, R. Okay, and which is also C. So N equal to sine I, so I is 90 degree, divide sine C. So from here, when we simplify the formula, so we get this n equal to 1 over sine C. So when we are given n, so we can find the critical angle of the medium, or the other way around. When they give you the critical angle of the medium, we can find its refractive index. All right. Okay. Next. Okay. So from here, what happened? The higher the refractive index of the medium, the smaller the critical angle. So from this equation, you can understand n is inversely proportional to C. Okay, I repeat, n is inversely proportional to C, which means when n is higher, C will be lower, and vice versa. When n lower, C will be greater, bigger angle. Okay, next. Okay, so this is a table shows to you example of a few medium together with their refractive index. Vacuum or air 1.00, air also 1, water 1.33, vegetable oil 1.47, glass plate 1.52, diamond 2.42, silicon 3.42, and germanium 4.05. So the optical density increases from vacuum to germanium. So the refractive index also increases from 1 to 4.05. Okay, so refractive index describe the degree to which a light ray are refract or bend as they pass from one medium to another. Okay, so from vacuum to germanium, what happened? The angle of refraction will be smaller and smaller and smaller. Mean the ability to refract right will be increases from vacuum to germanium. So they are closer to the normal, the refracted ray, right? Okay, now this is a few example of question related to the second learning standard. Okay, let us try. Diagram 6 show light refracted by a medium P. Okay, medium P is unknown medium P. So now the light travel from air into medium P. Okay, students. Can you tell me what is the angle of incidence here in A? What is the angle of incidence in air? You are given angle here 45 degree and here 122 degree. So what is the angle of incidence? Okay, let us see some answer. What is the angle of incidence here in this diagram? Okay, angle of incidence. Where to look angle of incidence, students? Mana? Kalau you tengok gambar saja. Okay, gambar ini bila you tengok, angle of incidence is here. Okay, here angle of incidence I. Okay, so this will be our angle of refraction. Okay, ini R. Okay, from this diagram, can you tell me which medium is denser? A, O, medium, P. Okay, from the incident ray and refracted ray. So here the incident ray, and you can see somehow the ray is refracted towards normal. Okay, so we understand medium P has a higher optical density compared to A. Okay, medium P has a greater optical density compared to A since the air refracted towards normal. Okay, where I greater than R down here. So the question asks, what is the refractive index of medium P? Okay, what formula we can apply here? Here does not involve critical angle, so we can use N equal sine I divide sine R. Okay, it doesn't give critical angle, so we can use Snell's law formula where N equals sine I over sine R. Okay, remember I must be in air and R is the angle in the denser medium, which is P. So I 45 degree, here 45, so this one also 45. And here is 32 degree. So your answer is 1.33, which is donkey. Okay, answer is donkey. Okay, are you clear with this question? Yeah, answer donkey. Very good. Okay, then, okay, what about the next question? Okay, now we are having diagram 4. It shows the light ray entering a transparent glass block. So the light is coming from A. So from A entering glass block. So given here the angle 38 degree and here 48 degree. So the question asks, what is the refractive index of the glass block? Okay, student, try to find the refractive index of this glass block. So first, you must find I and R first. Okay, I and R. So what is I? What is R? Okay, so where to look at I? I is here. The angle between incident ray and the normal. So this is our I. And R is here. Okay, so this is R. What is R? R is angle between the refracted ray and the normal line. You don't take mistakenly 38 is I, 48 is R, or your calculation will be wrong, right? So what will be the answer for this question? So what formula to apply? So here also does not involve critical angle. So we can use N equal sine I divide sine C. So, what is your answer? You jawab apa? Tengok jawapan. B, Cik Hang say B. Okay, so let us check. So this is the calculation. So we use n equal sine I divide sine R. So sine I is 42 degree. How to find 42? 90 minus 38. So here is 52 degree. And down here, okay, betul tak ni? Ni salah ni, betul. Sine 48. Bukan sine 48. Di sini berapa? What is the angle here? 90 minus 48. So 90 minus 48 should be 90 minus 48 should be 90 minus 48 berapa? 90 minus 48. So here should be sine 42. Okay, I make a correction there. Here supposed to be sine 42. Okay, so is the answer correct? 1.1a, sine 52 divide sine 42. What is the answer, student? Okay, so answer correct 1.1a, is it? Oh, cikgu salah type saja sana, sine 48 supposed to be sine 42. So is the answer B? Can you check? Sine 52 divide sine 42. I don't have scientific calculator with me now. So what is the answer? Sine 52 divide sine 42. So answer is 1.1a. The answer is correct, right? Only the calculation I show is wrong. Okay, so answer is boy. Is it boy? 1.18 correct or not? Can you check? Chi Hang and Jiaren, check for me. Sine 52 divide sine 42. Correct or not? 1.18. The rest also please check for me. Yes, correct. Okay, the answer is correct. Only the typing error here supposed to be 42. I typed earlier 48. Alright. Okay, next students. Okay, this is the next question. We have diagram 12 shows the path of light ray pass through two medium. Given refractive index for each is N1 for the first medium and N2 for the second medium. Okay, now we have the incident ray here, and this is the refracted ray which is exactly at the boundary. So we understand here I is equal to C. Okay, when R is exactly 90 degrees, so I is now also called as the critical angle. Okay, the question asks you which of the following will produce total internal reflection. Okay, which of the following will produce total internal reflection? Okay, the first choice, I increases N1 greater than N2. B, I decreases N1 greater than N2. C, I increased N1 less than N2. And D, I decreased N1 less than N2. Okay, so do you remember the two conditions I mentioned just now? So first condition, okay, the light must travel from denser to less dense optical medium. High density will have higher refractive index. Okay, so higher density medium will have higher refractive index. Second, I must be greater than C, which means I must be increased. So you can reject B, you can reject D. Why? Because it shows I decreases. So this one we can reject. Okay, this one also we can reject because it say I should be decreased. So the option is either A or C. So which one? I increases. Okay, then which mean this is the light ray. We increase I. Okay, we increase I. Then total internal reflection will occur. Okay, where the angle of incidence here equal to the angle of reflection here. So which mean which one must be greater than which one? N1 greater than N2 or N2 greater than N1? So answer, let us check for your answer. What do you say? So answer should be A. Okay, answer should be A. The first medium must be a high optical density medium. So answer is A. I increase, N1 greater than N2. Okay, so this is the clue. High optical density medium has high refractive index. Okay. Okay, next, students, next exercise question. Sorry, I didn't put number on the question, so this is the next question. Okay, diagram 9, it shows a light ray propagating from glass, okay, into water. So this is glass, this is water. Okay, so this is multiple combination question. First, second, third, and then we have option A, B, and C. Okay, the question is, what can possible happen to the light ray in a water if the refractive index of the glass is bigger than that of the water? So this is the very important clue. It tells you refractive index of glass bigger than that of water, which means glass is higher optical density medium, where water is low optical density medium. So which means now our light is travel from higher optical density medium to a lower optical density medium. Okay, so what possibility that might happen? Number one, possible or not refract towards normal. From high dense to less dense, is it refract towards normal? Supposed to be away, right? So this one refracts away from normal. Okay. And then C, is it possible experience total internal reflection? Possible, because travel from high optical density to low optical density. When I greater than C, then total internal reflection. So which one is the possibility? This is the second and the third choice. Yeah, refract away from normal. It refract away from normal. Example here. Okay, when we increase I, okay, let's say I is now here. Okay, so angle of refraction increases. Let's say here at the boundary. Okay, and then we increase somehow here. Okay, the third line. So what happened now? I greater than C, so total internal reflection occur. So at this point, I less than C. Here, I equal to C. And here, I greater than C. So the possibility is number 2 and number 3, which is C. Okay, got it? So then, are you following me until this point? So the clue is high refractive index, high optical density. Anything you would like to ask? You can open your mic or type your question in the in-call messages. Boleh? Are you doing good so far? Am I too fast or maybe too slow? Maybe you can give some response. Or now the speed is just nice. Okay? I can't see you. I can't see your gesture, or I cannot see your face. So I hope you can respond through your wording here, or at least by opening your mic. Okay. Boleh. Okay. If no questions, so let us continue. Okay. Okay. So this is the third learning standard, students. Okay, later we will see a few examples of a natural phenomena and a few applications in a devices involving total internal reflection. Okay, the first one, the natural phenomena. Okay, this is formation of a rainbow. Okay, formation of rainbow. Second diagram here is called as a mirage. mirage, where when you are driving in a very hot afternoon, you will see in front of you there will be appear a puddle of water in our road surface. Macam ada lopak air di atas permukaan jalan. But when you go closer, it disappear because actually it is not there. That is only the image of the cloud above the sky. Okay, so let us check one by one. First, formation of rainbow. I believe you learned this earlier in your lower form. Formation of rainbow actually involving multiple phenomenon, okay, such as refraction of light, and then total internal reflection, and then dispersion of light. There are three phenomenon involved. First, refraction of light, when light travel from the air entering the raindrop. Okay, and then second, inside the raindrop, total internal reflection occur at the back part of the raindrop. And then the third phenomenon is dispersion of light. When the light comes out from the raindrop, the white light disperses into 7 different colors according to its wavelength, arranged according to its decreasing wavelength from red to violet. Okay, so what happened? How do rainbow form? Okay, so first, white light from the sun. Okay, visible light, white light from the sun enter the water droplets. So this is the first phenomenon, refraction. Okay, because light travel to two different medium from A entering the water droplets. So refraction occur, and then inside it will disperse into 7 different component, as you can see in this GIF here. Number 1, and then dispersion started. So here at point 2, total internal reflection occur, and then here refraction occur again, and then for another dispersion. Okay, so in the second point, what happened? So all these different colors experience total internal reflection, okay, at the back part of the water droplet inside. Okay, and then third, what happened at the third point? The light ray reflected experience refraction. Okay, so first refract, then total internal reflection, and then here refract again. Then when it comes out, it disperse. Disperse means it's scattered into 7 different colors. So we see the product as rainbow. Okay, so this is the sequence from number 1, number 2, number 3, and number 4. Tak pernah keluar lagi SPM. Describe the formation of rainbow. Mirage sudah pernah keluar. Okay, but formation of rainbow, I think never come out yet. Right? Okay, then this is the second natural phenomenon, mirage. Okay, so what happened here? I took this diagram from your textbooks. You can see the number. It is according to the notes here. Number 1, okay, this is number 2, and this is number 3. Our eye observer when we are driving inside a vehicle or a car. So what happened here? The layer of A above the surface is hotter. Okay, in the afternoon, semasa tengah hari yang panas, the air above the road surface, udara di permukaan jalan ni is hotter, lebih panas. Okay, so the upper layer is cooler. Okay, layer above is cooler, so the air down here is hotter. So what happened? The optical density of the hot air is less. So hot air here has less dense. So cold air above is denser, right? So what happened? It means the light travel from high density to low density air. Okay, so light travel from upper layer to the lower layer are gradually refracted away from normal. Okay, from denser to less dense, so the light refracted away from normal. So what happened? The angle of incidence is become increased from layer to one layer. The angle of incidence will be increases. So do the angle of refraction will be increases until it reach one point where angle of incidence greater than the angle of refraction. So, where angle of incidence greater than the critical angle, then by that time, total internal reflection occur. So what happened? The light ray will be refracted back upwards, entering the eyes of the observer. So we will see the object up here, cloud will be formed below the road surface, and we see it as a pool or puddle of water. Okay, so you can read back from number 1, from number 2, and then from number 3. The idea is the light ray traveling through an air of different density, from denser cold air to less dense. So it refracts away from normal. Okay, then angle of incidence increases. When finally it reach one point where angle of incidence greater than critical angle, so total internal reflection occur. Okay, then the light enter the eyes of the observer, so we will see the image of the cloud appear on the road surface as a puddle of water. Okay, so this is mirage, a very important phenomenon involving total internal reflection. Okay, okay, now a few application in devices. Okay, so this is a few example. This is using optical fiber. This one optical fiber, and this is also endoscope, okay, in medicine. And also we have periscope in submarine, right? Okay, so we take a look at the prism periscope first. So you can find prism periscope in a submarine. Okay, for example, so prism periscope consists of two prism, a pair of prism, 45, 90, 45 degree. The prism is 45, 90, 45 degree. Okay, the prism. So what is the purpose of a periscope? It is used to see object behind a barrier, or in a submarine, it is used to observe an object above the water surface. Okay, it made up of two right angle prism. Right angle prism is 45, 90, 45, the angle. Okay, and then so what happened here? The object is above here. So this is the image appear on the eye of the observer. So what happens to the light ray from an object? You can see these two light ray coming from the object travel along the normal to the side AB here. Okay, of the upper prism through the opening. So this is the opening of the periscope. Okay, so what happened to this light ray? The light ray reach side AC. So this is light AC. Okay, without refraction. So you can see no refraction here, but total internal reflection occur. Okay, angle of incidence is 45, which is greater than the critical angle of the prism 42. So at this age, total internal reflection occur. So the light will be travel downward here, okay, along this path, right? Okay, then what happened next? From here, now it reached the second prism below here. So these two light reach the second prism. So the reflected light travel downwards along the normal side to DE of the lower prism. So what happened here? Again, total internal reflection occur, okay, at this side, DF. So finally, the reflected light emerge from side EF, okay, and enter the eyes of the observer. So we will see the image formed with this characteristic. It is upright. See, the object is upright, image also upright, okay, and it has same size as the object, okay, upright and same size as the object. Another characteristic, it is virtual. All right, okay, next we have optical fiber. So if you ask, total internal reflection occurs here first, then down here. Okay. Okay, next we have optical fiber. So what do we use optical fiber for? Any idea? What is the use of optical fiber? Give one example of use of optical fiber. So we use a lot in communication and also in medicine field. Dalam bidang perubatan pun kita banyak guna optical fiber. Okay, students. So it's mentioned here widely used in the field of telecommunication and medicine. So the structure consists of two important parts. Inside is the inner core, okay, and outside is the outer cladding or the outer core. Outer cladding, inside is the inner core. So it is made from pure glass, okay, or plastic fiber. So this optical fiber made from pure glass or plastic fibers. Okay, so the inner core, students, has a high refractive index. Okay, and outside it is surrounded by a layer of cladding with a lower refractive index. So if you compare these two structure, inner core has a higher refractive index, which means high optical density. Okay, the outer cladding has a lower refractive index, mean lower optical density. So inside, light travel from the inner core to the outer cladding, mean light travel from the high optical density to less optical density medium. So this will allow total internal reflection occur inside when I greater than C. Okay, as you can see in the diagram below here. Okay. Okay, this is a GIF, show how total internal reflection occurs in optical fiber. So the light signals enter one end of the optical fiber and it experiences total internal reflection continuously along, okay, along the optical fiber until it reach the other end. So same thing happen when the doctor use the endoscope, okay, to examine or to diagnose the condition of the internal organ of the patient. So the light travel and undergo continuous total internal reflection until it reach the other end. Okay, so what is the advantages of using optical fiber? Okay, so number one, signal can be sent rapidly without any disturbance from electrical signal. So it sends the signal very fast. Okay, so in medicine we can see the image in a short time, and also in telecommunication the signal or information is sent in a shorter time. Okay, we can send more information simultaneously in a shorter time. Komputer sekarang pun banyak guna optical fiber. Okay, students. Third application is the cat eye reflector. So where can you find this cat eye reflector? Okay, so this is assembled along the road. Ada dapat pada permukaan jalan. Sometimes they assemble at the border of the highway, di tepi tu. Okay, but mostly they're assembled at the road surface. So this cat eye reflector works based on total internal reflection, especially to help the road users at night or during dark condition. So what is the purpose? They use for safety purpose for road users, especially at night. Okay, so how is it function? You can see the light ray from a car headlight. Okay, here the light ray from the car head enter at this part. Okay, so what happened inside? It experienced total internal reflection at the back part of the reflector. So it will be reflected back to the eyes of the driver or the pedestrian or to the road users. Okay. Then this one, another thing, fountain, water fountain, colored water stream. Where in Malaysia we can find this? Do we have somewhere in Penang? Actually, we have one in Bertamputra in Setia Fountains. Do you know anywhere you can see this in Penang? Boleh tak? Siapa yang suka berjalan-jalan tu pernah nampak water fountain here somewhere in Penang? Okay. So the colored water stream. Okay, so actually this is a laser beam which enter the water stream. It is experienced multiple or repeatedly total internal reflection until it comes out from the end of the water stream. So this is one example of short experiment. You can try this at home. Okay, you fill up a bottle, okay, with colored with water, plain water, and then you highlight. Okay, you introduce a laser pointer here along the hole. Okay, so you will see the light will travel together with the water that comes out from this hole, because what happened along the water, the light has been experienced multiple or continuous total internal reflection. So the water that comes out appear to be colored water. Actually it's a plain water, but when we introduce green fluorescent or red fluorescent color here, it appears that the water comes out from this hole to be colored. Okay, actually that is the light, okay, that move together with the water along the water, which experience total internal reflection. Okay, so this situation show the water stream acts as a light pipe to guide the laser beam from one end to another. So the laser beam experience total internal reflection from this end to the other end of the water stream. Okay. Okay, students. So I guess we have come to the final part of this learning standard to solve problem involving total internal reflection. Okay, can I have some response for you? Are you following me until this point? Boleh faham tak total internal reflection? Anything you would like to ask or any part you would like me to repeat if you are not very clear with, I can do it for you. Okay, are you still there, students? Okay. Remember, at the end of this session, I need to take a photo as an evidence. So I hope you can give your cooperation to turn on your kamera. Boleh ya, nanti dekat akhir buka kamera kita ambil gambar. Tak perlu malu lah, ni semua kawan kamu saja. 4A, 4B, tak ada budak kelas lain. Okay, again, anything you would like to ask? Ada apa nak tanya tak? Weizer, Junbin, Min Hui, Xin Yu, Jingsen, who else we have here? Yi Ji, Xiang Jie, we have Suan Yin, Jin Yang, okay, Jian Tong, Yi Wei Roshan, Lei En, Wu Yang, Hok Yan, Wei Xin. Okay. We also have Harish there. Okay, Emily, Derek, Zan Hong, Kai Lun. Okay, Yiwen Chon Yang, Jia Xian, Wai Qing. Okay. Again, anything you would like to ask students? Okay. Okay, let us try to do a few example of SPM past year question involving total internal reflection. Okay. Okay, students. Question number 7. Okay, they give you diagram 2.1 and 2.2. Okay, in 2.1, it shows the structure of a prism. Okay, to be used for building a periscope shown in diagram 2. So we are using this prism to build a periscope in diagram 2.2. Given the critical angle of the prism is 42 degree. Okay, so you can highlight this. So first, what is the meaning of critical angle? Okay, anyone, what is critical angle? What is meant by critical angle? Okay, anyone, you can type your answer in the in-call messages. Okay, so this is critical angle. Okay, you can write your answer there. So critical angle is, I think this one is given, right? The answer. I forgot to erase if I'm not mistaken. Okay, critical angle is angle of incidence in the medium of higher optical density when the angle of refraction in the medium of lower optical density is 90 degree. Okay, so the keyword is angle of incidence. Second keyword, medium of high optical density. Okay, the third keyword, angle of refraction in medium of low optical density is 90 degree. Okay, So this is the answer for A, the meaning or definition for critical angle. Okay. Okay, are you done with A? I repeat, critical angle is the angle of incidence in a medium of higher optical density when angle of refraction in the lower optical density medium is 90 degree. Okay, what about the second question? Okay, in diagram 2.3, on diagram 2.3, you have to complete the ray of light after entering the prism. So here the light is entering at the normal, okay, at this border. It enter at normal at 90 degree. So any refraction occur here, student, when the light entering at the normal, any refraction or not? Okay, any refraction or not occur here when light entering the prism at 90 degrees. So no refraction, the light will continue travel in a straight line until it reach this side. Okay, so you can draw the first light. Okay, here no refraction occur, light continue travel in a straight line until it reach this side. Okay, so the question, what happened after this? Where will it go? Okay, will it refract outwards or will it undergo total internal reflection? Okay, what do you say? After reach this side, what happened to the light ray? Refract outwards away from normal or it experienced total internal reflection? Okay, which one? Which one occur? Refract outwards or undergo total internal reflection? Okay. Before that, they give you the critical angle of the prism is 42 degree. Okay, so what happened here? Okay, so this is the diagram we are drawing. So first, yeah, and then here, to know where it goes, so first you draw the normal. You draw the normal line. So this is our angle of incidence here. Do you know what is the angle here, students? Can you tell me what is the angle here? Angle of incidence here. Here we have 40 degree. Here is 90 degree. So what is the angle here? So angle up here will be berapa? 90, 40, total is 180, right? So here is 90, here is 40, which means here is 50 degree. Am I right? So if here is 50 degree, which means our angle of incidence here is 30 degree. 30 darjah sini. 30 degree. So what is the situation now? Is I greater than C, less than C, or equal than C? So I now less than C. C is critical angle, 42. I is 30 degree. So what happened? Refraction occur. Yeah, refraction occur. So it will refract away from normal. Okay, so away from normal, which mean move at this direction. So this will be our angle of refraction. So this is the correct diagram. It refract to the air away from normal. So how to explain? They have give one reason. So what is our reason? So we understand light enter the prism along the normal, so it is not refracted. Okay. Second, when light ray coming out from the prism, it refracted away from the normal. Okay, total internal reflection not occur because angle of incidence less than critical angle. Okay, so this is the explanation you may write. Okay, you can copy the question, the reason, and the drawing as well. Okay, I erase this part first. Okay. So here angle of incidence 30 degree. You can mark or not, no problem, as long as you draw the ray diagram, you show the normal, and you draw the refracted light after coming out from the prism to the air. Okay, from the prism to the air. If you are done with this, please say done so I can go to the next slide. Thank you. Okay, let's see who have done with this answer. Nobody respond yet. Okay. Am I still sound clear to you, students? Okay, thank you. Who is this Helly? Sorry, cannot recognize you because you are using other account than MOE. How to get 30 degree, Jiaren? Okay, how to get 30 degree, no problem. Okay, you look at this side. Okay, so this is a triangle, right? We have 40 degree up there. Here is 90 degree. Okay, so here is 90 degree. So which means here is 50 degree, right? 40, 90. So here is 50 degree. So if here is 50 degree, so which means here is berapa? So sorry, 40 degree. Sorry, bukan 30, 40. Sorry, my mistake. Okay, so here is also 40 degree. Total here is 90. Okay, so here is 50, which means here is 40. Okay, so angle of incident 40 degree. So I 40 degree still lower than critical angle, which is 42. Okay, C is 42 degree from the information at the front. Okay, so our situation now, I less than C. So refraction occur. Okay, thank you for your question, Jaren, and to correct my drawing here. Okay. Okay. Oh, already provided. Oh, okay. Thank you. Oh, Hallie is Jonathan. Thank you for introducing yourself. So got it now, yeah? The angle of incident 40 degree, which is lower than the critical angle 42 degrees. So total internal reflection does not occur, only refraction. Okay. Okay, then students. Question C. Okay, based on your observation in 7B2, the student found that a few modifications should be made so that the prism can be used in periscope. So 42 degree, the prism used earlier cannot use in periscope because total internal reflection does not occur, only refraction. So these are the modification need to be done by the students. First, angle of prism use. So what kind of prism we must use here? We must use a right angle prism. Okay, you can write right angle prism or prism with angle 45, or this is another option, 45, 90, 45 degree prism. Okay, it is a right angle prism. Reason, so that total internal reflection can occur. Okay, reasonnya senang saja, so that total internal reflection can occur. Okay, then D, so we have draw a new one. Okay, we have to find the refractive index of the plastic prism used. Okay, this is based on diagram 2.1. So what is the refractive index of the prism? So we can use this formula since the critical angle is given 42. So we can find, and the refracted index is, refractive index is 1.494. Please don't round up to 1.5. Okay, or don't put just 1.49, you better put 3 decimal places, 1.494. Okay, this is the related diagram to find the refractive index from this formula, n equal 1 over sine C. So C is given 42 degree. You just do the substitution. Okay, next. Okay, this is the next question. Now you are given diagram 11.2 and 11.3. 11.2 is glass. 11.3 is diamond. Okay, now in both diagram, light is entering from air, entering the glass here, and then this is the second edge. Okay, in the 11.3 diagram, light ray is coming from the air, entering the diamond, and then it reach this edge. Okay, so this is the information given. Refractive index for glass 1.50, you can highlight, while 2.42 for the diamond. Okay, so the first question, find the critical angle for both diamond and glass. Okay, student, what is the critical angle? How to find? When you are given refractive index, so C can be determined from this equation. Okay, N equal 1 over sine C. So we replace for diamond 2.42, the refractive index. For glass, it is 1.5, which means the critical angle for diamond 24.4, and for glass 41.8 degree. So here you can see that when the refractive index is higher, the critical angle will be lower. Okay, critical angle higher, refractive index lower. Okay, second, you are asked to copy diagram 11.2 and 11.3 and then complete the path of light ray in both glass and diamond until it finally emerge from each object. Okay, so how to draw? Okay, you draw for both glass and diamond. Mean your drawing must start from here. So from here, what happened? Where will the light go? Is it will undergo total internal reflection, or it will be refracted to the A, out from the medium? Okay. So you can try practice drawing and see what is the differences. Okay, now for glass. Okay, for glass first. So this is the incident ray from the air entering the glass block, and this is the refracted ray. And then inside, this will be the incident ray, and then where will be the refracted ray? Okay, so this is the angle of incidence given 30 degree. From our calculation, students, what is the critical angle for the glass? 41.8 degree, right? So now what is the situation here? I is 30 degree, which means I less than C. Okay, I is now less than C for the glass. I 30 degree, C 41.8 degree. So what happened? Refraction will occur. Refract to where? Towards or away from normal. From glass to A. So from this point, refract away from normal. Okay, away from normal. So it will be refracted downwards. Okay, here. Okay, so this is our angle of refraction. Okay, since it is refracted away, so I less than R. Or you can write R greater than I. Okay, here. So this is the correct drawing. So one phenomenon only involved here, refraction. No total internal reflection. Okay, what about diamond? Okay, now diamond, this is the angle of incidence in the diamond medium, 30 degree. Okay, now what is the critical angle for diamond? 24.4 degree. So our situation now, I greater than C. So when I greater than C, what happens, students? Yes, total internal reflection occur. So from here, where it go? Total internal reflection. So it will be reflected back to the medium. Dia pergi sini. So here 30 degree, angle here also 30 degree. Okay, then it will reach this edge. Okay, so next from here, where to draw? Any more total internal reflection, or it will be refracted outwards. So we have to draw first the normal. So this is the normal line. And then you have to find what is the angle of incidence here. Macam mana cari angle of incidence here? So can you tell me what is the angle of incidence here? Berapa angle of incidence di sini? If this two line is parallel, if this two edge is parallel, angle here also 30 degree. Which mean, again, I greater than C. So, total internal reflection occurs again here. Okay, sini 30 degree, here also 30 degree. And now, it reached this edge. So, at this edge, what happened? Any more total internal reflection, or is it refraction? So, we draw the normal. Okay, draw the normal. So you have to find the angle here. Okay, what is the angle here? So can you tell me what is the angle here? Berapa? Macam mana kira sudut di sini? Who is mastered in mathematics, especially topics for angle? Okay, so what happened here? You'll find the angle here is great. Angle of incidence here will be sorry for the interruption. So what will happen here, students? So no more total internal reflection occur here, only refraction. So it will refract away from normal. Okay, the light will be refract away from normal. So we have no 1, 2, 3 lines. Here only one line, single line. Okay, involving refraction. Here involving first total internal reflection, here also the second total internal reflection, and here refraction occurs. So finally, the light ray emerge or comes out from the diamond at this edge. Okay, did you get the drawing or did? So this is comparison between glass and diamond. So that's why we are using diamond in producing jewelries, especially accessories for women, because of the multiple total internal reflection occurs inside the diamond, so cause it to sparkle. So at each point total internal reflection occur, the sparkle will produce there. For example, here it will be sparkle at this side. Here also will be sparkle at this side, the shining. Okay, shining properties. Okay, so that goes for this page. Okay, do we have any more question left? See first. Okay, this one. Okay, the next question, students. I think we are about to come to the few last slide. Okay, so let us continue with this question. Okay, again, you are given diagram 2.1 and diagram 2.2. It shows light ray entering glass prism. Given the refractive index is 1.5. So you can highlight this information. Okay, it is the same prism, but the light is entering from different angle. Okay, here it comes from this direction. Here it travel exactly at the normal. Alright? Okay, so first, find angle theta. Okay, how to find angle theta? Theta is here in diagram 2.1. What is angle theta? Can you find angle theta? Any idea how to find angle theta? Okay, so what can we do here? We can reverse the direction of arrow. Okay, the arrow can come from here and then move here. So here we can use this angle of incidence at 90 degree. Then we can find theta as angle of refraction. So the calculation is as shown here. Okay, or you can use n equal to sine c because theta now is critical angle. Okay, theta now is, if you don't want to reverse, also no problem. We can use the relationship between angle of critical angle and refractive index. So n equal 1 over sine c because when r 90 degree, theta also known as critical angle. Okay, so it is 41.81 degree. Okay, and 1.5 given in the question. C we are looking for. So 41.81 degree is angle theta, which is also the critical angle for this prism. Okay, and then in diagram 2.2, you have to complete the light ray path from point O. So what happened after point O, student? Is it refracted away from normal or will it experience total internal reflection? Okay, so we check the angle of incidence. What is the angle of incidence here? Berapa angle of incidence here? Okay, so this is 45, this is 90 degree, this is also 45, right? Okay, 45, 45, 90, 180, which means the angle here is 45 degree. So 45 degree greater than C. So what happened? Total internal reflection occur. Here I greater than C. So total internal reflection occurs, so it will be reflected downwards. Okay, so this is how we complete the ray diagram. So based on your answer in B1, so what is the phenomenon involved? So the light phenomenon involved total internal reflection. Okay, so the idea of solving this question, okay, the first idea, the clue is here. R 90 degree, theta is critical angle. And for this one, the clue to solve 2.2, you must know what is the angle of incidence here. So since it is greater than C, so total internal reflection occur. Okay, the light phenomenon. Total internal reflection. Okay, C. Diagram 2.3 show a cross-section of a simple periscope. So the object is up here and this is the eye of the observer where the image will be observed at. So you have to draw the position of the prism in the periscope. So how to place the prism in this periscope. So how many prism we must use? We must use 2 prism. One to place here and one to place downward, okay, at the bottom. One place upper and one place below. So how to draw the prism? Okay, we put the prism in this way. Jangan letak terbalik kena letak macam ini. Sometimes the student will draw in this direction. Banyak kali jumpa pelajar nanti dia lukis macam ni. You lukis macam ni and then this side you draw in this way. If you put in this way, there's no way total internal reflection will occur. So this is the wrong way to place. So how to place? You must place the straight edge. Okay, here. Sini mesti yang lurus. So light enter the prism at normal. Macam ni. So light entering the prism at normal. So initially no refraction. Sini. Okay. At the second A, so here at this A, total internal reflection. Okay. And down here, how to draw? Same also. Here where the light enter, must use the straight plane. Okay. And then we put in this way. Lukis bagi betul lah. Cikgu punya ni tak lurus. Okay. So here total internal reflection occur. We draw the arrow as well. Here also total internal reflection occur. So it enter the normal in a straight line, so no refraction. So it reach this end, I greater than C, then again total internal reflection occur. Okay, this one. Okay, as shown it. In this draw single line, but I prefer you to draw two light rays. Normally we draw two light rays in SPM question paper. Alright. Okay. So this is the idea. Sorry, it's written in Malay here. I forgot to edit this part. So first, how you are going to give mark? Okay, first, the position of the prism must be correct for both. Okay, and then total internal reflection occur twice. Okay, total internal reflection occur twice. First here and second down here. Okay, for 3 marks. Okay, students. Okay, this is the decision making question. Okay, for question D. Sorry. Okay, now you have table 2. Again, okay, we are choosing a suitable element or suitable material to be used in a periscope. So we have three choices, three options. Prism P, Prism Q, or Prism R. They give you the refractive index for each. 1.52 for P, 1.46 for Q, and 1.43 for R. And then the size of the prism. Big for P and R, and then small for Q. Okay, so based on this table, you have to state suitable characteristic and give one reason for each. Okay, so first, determine the most suitable. Okay, number 1, refractive index. So how to answer this? Can we write number 1.52 or 1.46, 1.53? So the refractive index should be high or low. That is here the best answer to write. So high or low, student, refractive index of the prism should be high or should be low, the refractive index. High or low, everyone, refractive index, it should be high. Okay, so high refractive index. Why must choose high refractive index? So the critical angle will be small, which means easy for total internal reflection to occur. Okay, remember, the higher the refractive index, the smaller the critical angle, which means easier for total internal reflection to occur. Okay, second, the size of the prism. Think logic. Better to be big or better to be small? So answer, bigger. Bigger size of prism. Why bigger? The bigger the size, which means more light will be enter. Okay, more light will enter the prism, or you can say the prism will receive more light. So when more light enter, it will produce brighter image. Okay, so receive more light, then it will produce brighter image. Okay, so which one is the better choice? P, Q, or R? So according to this aspect, so we choose prism P with the refractive index of 1.52, which is the highest among 3, and it has big size of prism. Okay? Okay, so I guess that's all for today involving total internal reflection.